In this video, we'll discuss physics. Physics is an important part of many games. Unity actually has two physics engines, one for 3D physics based on the PhysX engine, and one for 2D physics based on the Box 2D physics engine. In Roller Madness, we'll be using just the 3D physics since this is a 3D game. Our objectives are to understand and modify colliders, understand and apply rigid bodies, and make use of physics materials. Okay, I'm going to go ahead and click on the rollerball game object. And notice the rollerball has a sphere collider on it. It was part of the original prefab that we got from the standard assets. If I click on the floor, notice the floor has a box collider on it. And if I actually look at these in the scene, you can actually see the collider. So let me go back to the ball and click F. This green circle is basically representative of the collider on this object. If I go over to one of these bumpers, it has a box collider, and you can see the green box. So the collider component is what is actually used to detect collisions on the game object. You could actually modify the size of that. It could be bigger or smaller than the actual size of the game object. For example, if I scale this up to, let's say, 5, you can see that green box got bigger than the actual mesh of the game object. So let me go back to 4. Of course, I could just change it here, or I could click Revert to Prefab, and it will go back to the options of the prefab. So by default, Unity physics does not allow colliders to overlap. So, when my ball is rolling and it hits the bumper, it prevents it from going through it. One of the options of a collider is the is trigger option. Let me go ahead and select this and play. And then roll over to that. You can see, whoa, I'm going right through this game object now. So by default, colliders prevent things from overlapping, but if you turn on this is trigger, it makes this into a trigger. So triggers are useful to detect a collision between game objects without actually preventing the object from passing through each other. So for example, the bumper could be an invisible object that when entered causes something to happen in the game, sort of like a pressure plate or that sort of thing. Right now you can actually see it, but if you turned off the mesh renderer, now it's an invisible object that the ball can roll into. When it hits the collider, an action could be triggered, for example. And we'll see examples of that as we continue. So let me go ahead and turn that back on, or I can just revert to the prefab once again. Let me go to the floor, and let's set the is trigger for that, and then play, and notice what happens. Let me go ahead and change my scene view so I'm focused on the ball. Go ahead and press play. And whoa, what happened? The ball fell right through the world because, once again, since we set the floor collider to be trigger rather than the standard, it didn't stop the collision from happening. So one thing that you could ask yourself is, why did the ball fall through the floor but not the bumpers? Let's go ahead and look at the ball, and notice the ball also has a component called the rigid body. Rigid bodies allow colliders to be affected by physics. So since the ball has the rigid body component, and notice one of the options of the rigid body component is use gravity. So that's basically, with the use gravity on, that applies a force constantly to the ball that pulls it down. If I look at one of the bumpers, there is no rigid body component on it. Therefore, it doesn't fall with gravity. It's generally a good idea to have rigid bodies on any game objects that have colliders and that are moving in some fashion, like the rollerball. So we looked at the use gravity setting on the rollerball. One other option of the rigid body is kinematic. If is kinematic is checked, the object will not be driven by physics. This is useful when you want to move the object directly through the transform. So with rigid bodies, you typically don't move the object. I mean, you can set it up through the transform, but once the game starts playing, you move it by applying forces like gravity to the ball. And the ball script actually moves the ball by applying forces. That's how we get the more natural rolling feeling rather than just moving it directly through the transform. But if you wanted to modify the transform directly through scripts, or if you wanted to have an animation on the ball through the animation system, which we'll talk about a little bit later, you would turn is kinematic on. But in the case of the rollerball, we want it to be affected by physics directly. We want it to have gravity, so we'll set it this way. The other options here, you can set the mass, the drag, and the angular drag for the game object. These are things that you can always play with and kind of see the results of. By changing these options, it will change how physics is affected on these options. So let me go back to the floor and of course turn the is trigger off so the ball doesn't fall through the world. So let me go back to the rollerball now, and let's look at the sphere collider. One option of colliders that's kind of interesting is called the material. Now this is very different than the material that has the shader and the textures that we've talked about before. This is really a physics material, and notice it's got a rubber option here. Essentially the ball sort of behaves like a rubber ball in this world when physics applied to it. So let me raise the ball up a little bit and just go ahead and hit play. And you can see it fell and it had a little bounce to it. Let me go ahead and hit the target here, and let's just set it to none and play again. No bounce. Okay, so that material on the collider, let me go back and switch it back to rubber, is what makes this have that little bounce. So you can see there's several physics materials. There's bouncy, ice, max friction, metal, wood, zero friction, of course, rubber. You could actually make your own physics materials. Under Create, you can create physics materials right here and set the options of bounciness and a few other options. So we have these bumpers in the world, and right now they're really not very bouncy. When you hit the bumper, you'd expect to be bounced off. So let's use the physics material for that purpose. So let me go to a bumper. Notice the box collider does not have a physics material attached. I'll go ahead and hit target and select bouncy. If I hit F, you can see which bumper this is. So if I play, now when I roll over to it, boom, it bounces off. If I hit one of the other bumpers, it has a little bit of a bounce because the ball is rubber, but not nearly as much as that other bumper that we had applied that physics material. So we like that, we want that. So let's go ahead and hit apply to the prefab on that game object, and notice all of the other bumpers now have that bouncy physics material applied.
As a quick review, physics are created through two components on game objects, the rigid body and the collider. The rigid body component enables physics on the game object, including gravity. Through the rigid body, you can specify the physical properties of the game object, such as mass. If a collider component is also attached, the rigid body will also detect collisions between game objects. While a collider is invisible to the camera, it determines the shape of the game object in terms of how it interacts with physics. The rigid body and collider work together to detect collisions between game objects. If is_trigger is set to true, objects can pass through each other, but the game can still detect the collision and respond accordingly. Colliders can have a physics material attached to modify its physical properties, such as make the game object bouncy. In the next video, we'll modify the player to control and look better.